Uppsala, old Uppsala, has always been at the religious center of Sweden. All around are reminders of its distant past. Viking kings, Nordic myths, a sacred grove, and a Christian cathedral. Beneath these mounds lie the remains of 3 early kings, cremated in huge burial chambers along with all they needed for their last journey. As late as the 10th century, this was the site of a Nordic pagan temple. In the sacred grove, men were sacrificed to placate the gods of nature. But by 1100 AD, things had changed. Christianity reached Gamla Uppsala, the pagan temple was torn down, and a Christian church erected. The worship of nature was replaced by the study of nature. Uppsala became the center for Swedish science. In some ways, the church played a major part in this, but in other ways it actually inhibited scientific inquiry, especially when it was slow to abandon the old ideas of Aristotle. One remarkable family closely linked with Gamla Uppsala is that of Anders Celsius. Not only is he buried here, but both his father and his grandfather were ministers in this church. They were also professors at the nearby University of Uppsala.
In the 18th century, religion still had a very strong position in Sweden, and they dominated the academic life. But of course, things had changed. And we can see Anders Celsius as part of this process, or as a link between the old university and the new one. His father and his grandfather had both been professors in astronomy, and his father had a big clash with the church because he was forbidden to teach about the Copernican view of the world, saying that the sun was in the middle of the universe. The church still wanted to say that the earth was in the center. But in Celsius' time, there was quite another atmosphere, although the church still had censorship up to 1766. Celsius was appointed professor before he was 30 years old, not only because he was very talented, which was obvious for everyone, but also because he intended to make a long journey abroad, which was very essential for an academic career this time.
During his travels, Celsius worked with a French scientific team in Lapland, studying one of the most important questions of the day, the shape of the Earth. Their measurements confirmed Newton's theory that the Earth was round and somewhat flattened at the poles. When Celsius returned to Uppsala, he took up his appointment as professor of astronomy, bringing great fame and prestige both for himself and for Swedish astronomy. Like Celsius, Carl Linnaeus was also keen to travel abroad and build up international links, this time in the service of botany.
When Linnaeus was 25 years old, he went to Lapland. And Lapland at that time was considered a very exotic country, just like the New World or the Far East or something like that. And then he used his knowledge of Lapland to be considered a very special scientist. He wrote his Flora Laponica, which made him an expert of this exotic country. So you can say that he used his Lapland experience as a kind of PR in the scientific world.
Linnaeus and Celsius were part of the great wave of scientific inquiry that swept Sweden in the 1730s and 40s. To understand this sudden promotion of science, we need to look back to the previous century. Sweden was then a great military power with colonies on the Baltic and prosperous trading links abroad. To reflect Sweden's status, the University of Uppsala was considerably expanded. Although it was the most northerly one in Europe, it became a seat of international learning. It flourished, but the teaching was mainly concerned with training clerics. scientific inquiry was of minor importance. The main university building, the Gustavianum, was named after its patron, King Gustavus Adolphus. A spectacular feature was the dome, added by Olof Rudbeck in the 1660s, built to house a new anatomical theatre.
This theatre is a unique creation, built on the roof, having windows all around so he could have lights from all directions. The theatre was used for anatomical dissections. They had bodies lying here, the doctor was showing, and the barber was using the knife and cutting in the body. But of course, the church didn't like that you carved in the human body, so they had very few original dissections. I mean, they could use one or two criminals, but otherwise they had to use dogs and cats to see how a body was constructed.
The splendor and ingenuity of the anatomical theatre reflect the confidence of the 17th century. But this gave way to gloom and despondency early in the 18th century, when Sweden suffered severe military defeat. Sweden was no longer a great power, and her economy was in ruins. But it was not only political problems that faced the government.
In the beginning of the 18th century, the greatest copper mine of Sweden threatened to peter out. And what happening then, during the 18th century, was that we have a constant search for new minerals, because the copper mine was very essential for Swedish economy during this time. And this means that during the 18th century, a lot of new mines were opened in Sweden. Gold mines, iron mines, and so on and so on. Chemist was a very important part in this search, because chemistry could do analysis on the newfound minerals and tell them what they did contain. Therefore, chemistry was very essential also for Swedish economy during the 18th century, and the government supported chemistry very much.
One of the aims of the new government was economic utility. In 1739, a new institution was inaugurated, the Royal Swedish Academy of Sciences. Its purpose was to promote practical science. The academy was established in Stockholm, the commercial and political capital. The university city of Uppsala was considered too traditional, even too old-fashioned for this new approach to science. The academy was founded to respond to a national problem. But even so, it looked to foreign models for its organization, in particular to the Royal Society of London.
The academy soon started out spreading the gospel of science to the Swedish public. In the first place, they wanted to influence manufacturers and peasants, trying to get them to use better methods for cultivating the soil, for manufacturing and so on. So there was a strong link from the outset between science and utility. The Academy got the royal privilege to publish an almanac from 1747, and the first little almanac was brought out in 1749. I've got it here. It is not a very huge book, but the circulation was very high from the outset, because everybody was interested in knowing these details on the sunrise and sunset, and even the weather forecasts that were published for each day for the coming year. For example, it says here from late February, it is most often coming a little snow, which makes transportation easy.
Linnaeus was the driving force behind the foundation of the Royal Swedish Academy of Sciences, and he was its first president. 2 years later, in 1741, he was appointed professor of botany and medicine at Uppsala University. He restored the university botanical gardens and systematically worked on his methods of nomenclature and classification. Scientific teaching and research were now beginning to re-emerge at the university. His method of binomial nomenclature was both economical and simple. 2 Latin names were all that was needed to classify every plant, animal, or mineral into its genus and species. In the garden, the plants are laid out according to his classification system. This system was based on the sexual characteristics of the plants.
Linnaeus divided the plant kingdom into 24 classes, and he got those classes by counting the stamens of the flowers. And the system is very simple in principle. The stamen are the male organ of the flower, and in that way he got the 24 classes. Each class he divided by the help of the pistil, the female organ of the plant. In that way you can look in the book of nature what class and order each plant has. So class 1, order 1 has 1 stamen and 1 pistil, and class 2, the order 1 has 2 stamens and 1 pistil, and so on. And when you come, for instance, to class 5, one of the big classes, where you have a plant like the Nicotiana tobaccum, the tobacco plant, you can see, of course, that it is class 5, order 1, because it has 5 stamens and 1 pistil in it.
In his sexual classification system, Linnaeus called this arrangement 5 husbands in 1 marriage with 1 wife.
Once he'd discovered this new system of classification, he soon got the idea that maybe he was called to his duty by God himself. He was sort of revealing the divine pattern behind creation. And this, of course, is a very strong dimension in what we call natural theology, that God has created this world in a benign way for the good of mankind. And this divine inspiration Linnaeus spoke of over and over again. He even called his disciples his apostles, and sending them out in the world, collecting new material, bringing information about creation in Asia, in America, in all the continents, would be a further strengthening of the knowledge of this divine creation, and thus even hailing God even stronger.
Celsius also had a mission: to reform the way astronomy was taught. His father and grandfather had been professors of astronomy, but they'd worked without any instruments, without even a telescope. During his travels abroad, Celsius bought instruments and installed them in his observatory at Uppsala. He also kept daily meteorological records, and it was this that led him to develop a satisfactory thermometer. His solution was to take the boiling and freezing temperatures of water as his 2 fixed points and divide the scale into 100 equal divisions or degrees. Today, we talk of the boiling temperature of water as 100 degrees Celsius. But that wasn't what Celsius intended.
Celsius is, of course, most known for his thermometer, which he constructed around 1740. He had the scale showing the boiling point at 0 and the freezing point at 100 degrees. This thermometer turned out to be very useful, and it was used in the Academy of Sciences in Stockholm. It also shows a link between the university and the academy, for Celsius described his thermometer in the proceedings of the Academy.
Celsius didn't live long enough to see the prestigious new observatory built by the Academy in Stockholm. Astronomy was now considered an economically useful subject. If you were an astronomer, you automatically became a member of the Academy. One astronomer was Per Wargentin. He was also permanent secretary of the Academy. He described the opening of the observatory in 1753 as the happiest day so far in the history of the Academy.
Wargentin was the first astronomer who came here, and he complained about the poor instruments that he had to work with. And so he wanted to buy some instruments from England, and it was very, very expensive. Actually, the cost of the instruments was about a fifth of the total budget for this project. Wargentin was making numeric tables about the eclipses of Jupiter's moons. And with his tables, a traveler abroad could decide his position, because the problem at that time was to decide your position in east-west direction. North-south, it was no problem at all. You could look at the sun and decide where you were. But east-west was very difficult. But with Wargentin's tables over the Jupiter satellite's eclipses, you could decide your position.
A plaque dominates one wall. It summarizes the reasons why the Academy set up the observatory. A belief in revealing the greatness of God's creation and a belief in economic utility. Part of it reads, "We will turn all that God has created to the usefulness of mankind, including the most distant bodies."
All the important scientists, Linnaeus, Celsius and others, they may have come up anyway. They may have made important contributions to science. But the collected efforts wouldn't have been there hadn't the Academy been there. For example, this big project of Linnaeus sending out his disciples, bringing in material from all over the world, it was an orchestrated effort that wouldn't have been possible if the Academy hadn't been there promoting it. The same is true for many other sciences as well. I mean, you can say the same about Swedish astronomy. It wouldn't have been the same in the 18th century hadn't the observatory in Stockholm been established, for example. So it was very important. On the other hand, it was still a minor academy in the European perspective. Paris and London academies were far bigger, far more important. But what else could you expect from a small state like Sweden?
Back at Uppsala, chemistry was finally given full academic status when the government established the first ever department of chemistry in Sweden in 1750. A department of physics was established at the same time.
You can see it's quite typical that chemistry was the strong share of this, because to chemistry a new institutional building was erected, and it was a two-store building, whereas physics only had 3 rooms in an already existing building. As chemistry was so closely connected with practice and with practical works in the mining, religion was not very important. I mean, the theoretical implications in chemistry was of no concern to religious persons and to the church, not to the same extent as, let's say, theoretical ideas in physics. So this means that what you could see in chemistry of religious support is just the rhetoric of natural theology. I say, look at what God has created, all this is good for Sweden. Usually you end an article or a speech with these words. So I haven't found any strong conflicts between chemists and the church during this time.
Under Torbjörn Bergman, chemistry flourished at Uppsala University. He attempted to do for chemistry what Linnaeus had done for botany. He worked at a classification system for all known minerals. The new science of mineralogy was a very practical part of chemistry. But Bergman also did something else. He carried out thousands of experiments to find out how chemicals reacted with each other. He carefully measured their weights, and in this way established an order for individual chemicals, showing which had the greater affinity. He compiled these results into affinity tables. Pharmacy was another tradition which led to the development of chemistry as we know it today. Pharmacists worked with natural materials to make medicines. One outstanding Swedish pharmacist was Carl Wilhelm Scheele, who worked for some time in Uppsala. During the 18th century, Swedish chemists led the world in the discovery of new elements, including cobalt, nickel, and manganese. By the 1770s, chemists in several countries were beginning to recognize that gases were chemical individuals, not merely impure forms of air. Using extremely simple apparatus, like an ox bladder, Scheele isolated many new gases, including those elements we now call hydrogen and oxygen. In all this work, he owed much to the inspiration and collaboration of Bergman. Science in Sweden reached its high point in the 40 years between 1740 and 1780. But then scientific inquiry began to tail off. Science had not fulfilled its promise of rebuilding the economy.
Towards the end of the 18th century, there was a decline in the atmosphere for natural sciences in Sweden. There was a shift towards belletristic and aesthetic disciplines rather. The king himself, for example, was particularly interested in theatre and not in laboratories. He created another academy for these disciplines. This it didn't mean, actually, that the laboratories were taken down. I mean, they were still working, but it's rather a shift of focus.
There is very often a picture saying that Swedish chemistry after Bergman declined, waiting for the new hero, Berzelius. And to a certain extent, that is right. But you could also phrase it this way, that chemistry in Sweden after Bergman did not decline. It just fell back to an ordinary Swedish level, which was by European standards good by this time.
Uppsala and Stockholm were no longer insignificant cities on the fringe of Europe. They were the places where important scientific work had taken place. Despite the shift in focus, despite the tailing off of scientific inquiry, Sweden now had the infrastructure it needed to move forward. The University of Uppsala, with its tradition of research, and the Royal Swedish Academy of Sciences in Stockholm, with its emphasis on promoting practical science. Sweden was no longer the great military and political power she'd once been, but science had helped her regain international prestige. Swedish men of science, like Linnaeus, Celsius, Wargentin and Bergman, had built up international links and had demonstrated the value of Swedish scientific inquiry in the 18th century.
The Open University has a scheme to allow other educational institutions to record copies of its programmes. For details, please ring 01908 858 766. That's 01908 858 766. Or visit our website